Welcome to the SAR channel, where sound and audio are demystified. Light is a type of electromagnetic wave defined by its wavelength, frequency, speed, direction of travel, vibration direction, and brightness. Optical systems like CDs, DVDs, Blu-ray discs, and fiber optics are built on these basic principles of light behavior. Most optical storage systems keep data on the surface of a flat disk, allowing quick random access and easy mass production. In these systems, the pickup and the disk never touch. Data is written and read using light. This contact-free design helps both the pickup and disk last longer and prevents damage from mechanical failure. Because there's no contact, the data can be placed under a clear protective layer that guards it from dust and scratches. However, the stored data must go through modulation and error correction to increase storage capacity and reduce errors. Optical disks last longer than magnetic media, resist heat damage, and are unaffected by magnetic fields. The compact disc, introduced in 1980, was one of the biggest breakthroughs in audio technology since sound recording began. It brought several new innovations to audio. ACD stores digital data that is read by a laser. Since the reflective data layer lies inside the disk, dust and fingerprints on the surface rarely affect playback. Error correction systems help fix most reading problems. Because no needle touches the disk, it never wears out, no matter how often it's played. This combination of digital storage, error correction, and durability made the CD a reliable format. Most importantly, it set a new standard for sound quality, offering a flat frequency response and very low distortion. The CD was originally developed through the collaboration of Philips from the Netherlands and Sony from Japan. Philips created the optical disc technology, while Sony developed the error correction methods. When these two technologies were combined, they formed the successful CD format. The standard set by both companies made sure that CDs and players from different brands would work together. The compact disc is an efficient way to store information. An audio CD holds stereo sound made up of two 16-bit data streams sampled at 44.1 kHz. A standard CD can play for up to 74 minutes and 33 seconds, though small changes to the format can allow longer playtime. With 16-bit sampling at 44.1 kHz, CD players usually have a frequency response from 5 Hz to 20 kHz with only a 0.2 decibel variation. They offer a dynamic range and signal-to-noise ratio above 100 decibels, and more than 100 decibels of channel separation at 1 kHz. Harmonic distortion at 1 kHz is typically below 0.002%. The rotation speed is extremely stable, controlled by a quartz crystal, and phase shift with digital filters is under 0.5 degrees. DA converters stay accurate within 0.5 decibels at negative 90 decibels levels. The 44.1 kHz sampling rate was chosen because it worked with the NTSC and PAL video formats used in early digital recording. Professional video recorders stored 16-bit digital audio as video signals, so the sampling rate had to match video frame rates. Because converting between rates was difficult, 44.1 kHz became the CD standard. A CD player's job is to read and extract the digital data stored on a disk. It begins by using a laser beam to read the information. To do this accurately, the player also uses optical tracking and autofocus systems. After errors are detected and corrected, the digital signal is processed to recover extra data called subcode information. Anti-imaging filtering is done digitally using oversampling filters. In oversampling, the sound data is split into left and right channels and sent through a finite impulse response filter. Extra samples are added between the original ones, raising the sampling rate. This shifts unwanted image signals to higher frequencies, where they can be easily removed by a simple analog filter without causing phase distortion. Finally, the processed data is converted into a format that matches the type of DA converter used. Most CD players use sigma delta converters. CD text lets extra information like album name, song titles, artist, composer, and producer be added to a disc during production. Players that support CD text can display this information on their screens. Making a disc involves three main steps: pre-mastering, disc mastering, and disc replication. Pre-mastering can be done in a studio or even on a computer, but mastering and replication need special machines found only in disc production facilities. Pre-mastering is the final step of recording and comes before mastering and replication. In this stage, an audio source is prepared to create the master glass disc. It contains the final, edited version of the content, recorded at the highest quality and stored on a reliable medium. For audio, the Disc Description Protocol DDP format is used to store an image of the Red Book data and PQ subcode information. In some cases, the audio may instead be saved on a CD-ROM as WAV or AIFF files. If you've enjoyed this video so far, please hit the subscribe button for more. Thank you. The DVD came after the CD and created new possibilities for digital optical disc technology. It improved on the CD in all aspects, offering much higher storage capacity and faster reading and writing speeds. The first DVD format was introduced in 1995. The DVD family includes several versions designed for video, audio, and computer use. Since its use grew beyond just video, the name Digital Video Disc was changed to Digital Versatile Disc, though most people simply call it DVD. While DVDs are based on CD technology, they use new physical designs and file formats. DVDs are the same size as CDs, but a single data layer can hold about 7 times more information. Regular DVD discs cannot be played in CD players. The process of making DVDs is similar to that of CDs, but it requires tighter precision and a few extra steps. Using high sampling rates like 96 kHz and 192 kHz might seem unnecessary since very few people can hear sounds as high as 24 or 26 kHz, which are still below the limits of 48 kHz and 96 kHz sampling. Most people can't hear above 20 kHz. However, these higher sampling rates help improve timing accuracy between the ears, resulting in better sound imaging and spatial clarity. The Blu-ray disc system was created to replace the DVD video format and to compete with the discontinued HD DVD format. Blu-ray supports both compressed lossy and uncompressed lossless audio formats. It can deliver very high-quality multi-channel sound and offers long playback times. Sony Corporation led the group of companies that developed the Blu-ray disc system. The Blu-ray disc founding group was formed in early 2002 and later became the Blu-ray Disc Association in June 2004. The first Blu-ray disc specification was released in February 2002. Blu-ray recorders appeared in Japan in April 2003, and the first standard discs and players were launched worldwide in June 2006. The E in blue was dropped in the name Blu-ray to make it eligible for trademark registration, since common words cannot be trademarked. A single-layer Blu-ray disc holds about 25 gigabytes of data, around 35 times more than a CD and 5 times more than a DVD, while a dual-layer disc stores about 50 gigabytes. Blu-ray discs are the same size as CDs and DVDs. The Blu-ray Disc Association also recommends that Blu-ray players support playback of both CDs and DVDs. The process of making Blu-ray discs is similar to that of CDs and DVDs, but because Blu-ray requires higher precision, some new and more exact manufacturing techniques are used. Blu-ray allows sampling rates as high as 96 kHz and 192 kHz, but it does not support 44.1 kHz or 88.2 kHz sampling rates. Thank you for watching till the end. To better understand each video, make sure to watch the previous ones. Some may serve as prerequisites for the next. If you have any questions or opinions, feel free to leave a comment. Until next time, subscribe and stay curious.